through the derivative of a log. We have only dealt with exponentials so far. So if I wanted to do the derivative of this, we could think of it, this is like log base a of x is equal to y. So if I asked you to write that in exponential form, it would be a to the y power equals x. And we've done the derivative of an exponential before. We know we prefer e's because e to a power is still e to the power, but a long time ago we talked about if we had a base other than e, we could still do it. It's still a to that power, but you have to have another times the natural log of the base. So if I said like 2 to the x, the derivative of that was 2 to the x times the natural log of 2. So a to the y, the derivative is a to the y times the natural log of a. But then we have to do the chain rule. What's the derivative of y?
1 or dy dx.
Equals, what's the derivative of x?
1.
So we get dy dx equals 1 over a to the y times the natural log of a. And we can go one more step. What is a to the y equal to? X. So if I subbed that back in, the derivative is x times 1 over x times the natural log of a. Now, just like when we were dealing with exponentials, we preferred e's because the derivative was nicer. The same is true with logs. Because if I had a natural log, that's like log base e. And what is the natural log of e?
Just e. Wait.
Just 1. You guys have forgotten all of your log stuff?
I thought this was...
Okay. So if I said the natural log of e, okay, and I asked you what that was equal to. So natural log is log base e. So that means e to the y power equals e. So what's y? 1. So when you have a natural log and an e, you can just drop it. So that will be our preferred method, because then if I said you had the natural log of x and I asked for the derivative, it's 1 over x times the natural log of e, but the natural log of e is 1, and it just becomes 1 over x. So that is what this next slide says. The derivative of a natural log is just 1 over x. So that will be what we are doing the majority of the time. If it's a log other than a natural log, so if it's a log base 10 or a log base 3, you'll have to add in the natural log of that base on the denominator. So, if I ask you to do this derivative, so we just had a theorem that said the derivative of a natural log is 1 over x, if it was the natural log of x. So it's 1 over the argument, which is x cubed plus 1. But we have to do our chain rule here. So times, what's the derivative of the inside?
3x.
So our derivative is 3x squared over x cubed plus 1. I want the derivative of the natural log of sine x. So the derivative of a natural log is 1 over the argument. We have to do the chain rule. What is the derivative of sine? So we get cosine x over sine x. Or what is cosine over sine? Cotangent x. What would I need to do here?
You get rid of the square root.
What would I write that as?
To the 1/2.
So then our derivative, we have to do the chain rule. So derivative of the outside, so the 1/2 comes down, inside stays the same, subtract 1 from the power, times the derivative of the inside. What is the derivative of natural log x? 1 over x. As far as cleaning that up, we have a 2 and an x both on the bottom. You have that natural log to the negative 1/2. Where does the negative power put it? On the bottom. So we have 1 over 2x times the natural log of x to the 1/2. So far, so good? So number 4, this one is not a natural log. So we're looking at the same way, it's 1 over the argument, but because it's not a natural log, we'll have to do times the natural log of the base. So 1 over, what is the argument?
2 plus.
Okay, times the natural log of 10. Just like when we did the derivative of e to a power, or if we had like a different number to a power, we had to add a natural log of that base. Same thing with the derivatives. With the logs, we just add the natural log of that base. But we have to do the chain rule here. What is the derivative of the inside? Cosine x. So we just get cosine x over 2 plus sine x natural log of 10. Last one. So I have the natural log of this whole thing. We know that if we have the derivative of a natural log, it's 1 over the argument, and my argument is that whole thing. But what am I going to have to do here? Am I done? No, we have to do the chain rule. So times derivative of the inside. How would I do the derivative of that inside? Quotient rule. So that's low. I'm going to write that as x minus 2 to the 1/2. D high, derivative of the top is 1, minus high, x plus 1. D low, so the 1/2 comes down, inside stays the same, subtract 1 from the power. Over low squared, if I took the square root and squared it, you just get the x minus 2. Okay. Let's see. Fraction and a fraction, what do we do? Flip and multiply. So that would put the square root on top, or I'm going to write it as x minus 2 to the 1/2 on top, and the x plus 1 on the bottom. Okay, let's see. All right. Let's go ahead and multiply this stuff together and see what happens. We have to distribute this to both terms on the top. So x minus 2 to the 1/2 times x minus 2 to the 1/2. What does that become? When I multiply these two, you add your exponents and it just becomes 2 to the first. So it's just an x minus 2. Minus 1/2 x plus 1. When I multiply these and add those exponents, we get the 0 power, so that part's gone. Is it proper notation to leave a fraction in a fraction? No. So easy option to get rid of that 1/2 would be take everything times 2 each term. So those cancel. So we get 2x minus 4 minus x minus 1 over 2x plus 1 x minus 2. Combine like terms, so we get x minus 5 over 2 times x plus 1 x minus 2. Alright, so that one involved a lot more algebra to clean it up, but the same premise. We do our derivative, so 1 over the argument, and we have to apply the chain rule. Questions? Okay, so here's what we've got. The 3.5 homework is due today, so you've got a little bit of time if you need to ask any questions on that. And then this assignment is due tomorrow. So once you finish 3.5 and get that